Welcome to Math Movies with Miss Feuer-Beck and Miss Veluti. Today we'll be solving 2-digit by 2-digit multiplication using the traditional algorithm. Let's start by solving 18 times 16. And the first thing that I need to do with the traditional algorithm is I need to rewrite the problem vertically. And when I do so, I want to always make sure that I'm lining up my place values. So you can see here that I have my 1s and my 10s lined up. As we go about this problem, I'm going to show you how it matches to an array so you can kind of understand what it is that we're actually doing. So now when we're doing the traditional algorithm, we're going to be breaking this apart. And what we're going to do is keep the 18 and we're going to break apart the 16 into 10 and 6. And so I'm going to be creating two simpler problems. I'm going to be solving 18 times 6 and 18 times 10. And those are the two steps that we're going to be doing. So I'm going to start right now always with, I start at the right. When I'm doing the traditional algorithm for multiplication, I always start in the ones place. So I'm actually going to multiply 6 times 8 right now to start. 6 times 8 is 48. So I'm going to put down the 8, and I'm actually going to bring the 4 over to the tens place. The reason that I'm doing this is because I'm not just solving 6 times 8 right now. I'm going to be solving 18 times 6 in this whole step. So I'm actually going to be doing 18 times 6 and figuring out what goes in this part of the array. So I'm combining the steps 6 times 8 and 6 times 10. And in order to do that, I start by doing 6 times 8 equals 48. And the 4 is going to get carried over to the tens place, okay? So now my next step is to do 6 times 10. Now I know that this is a 10, but for right now in the algorithm, I just need to think about them as digits. So I'm just going to think 6 times 1 is 6, plus I have to add this 4. So it's 6 times 1 is 6, plus 4 is 10. So I'm going to put down the 0, and then I don't have anything else over here to carry over to the hundreds, so I can take the 1 and I can put it in the hundreds place down here in my solution. Now if we think about this, this makes sense because 18 times 6 is what I just solved, and 18 times 6 is 108. So I'm going to go ahead over here and fill in my array. I just solved 18 times 6 and got 108. Now, because I'm in the traditional algorithm and I'm going from this place, 6 times 18, to now I'm going to be solving 10 times 18. Because I'm moving over a place, I need to account for that. And in order to do that, what we like to do with the algorithm is people put in a placeholder to show that we're moving from the ones place to the tens place. And I always like to, it's really considered a 0 as a placeholder, but I like to put an X through it just to remind myself that it is my placeholder. So I've put in my placeholder. And now I'm going to solve 10 times 18, and that's what I'm going to be figuring out goes inside here. Now in order to do that, again, I'm going to think of these numbers as digits. So this 10 is really just going to be thought of as a 1 right now, and I'm going to multiply 1 times 8. Now 1 times 8 is 8, so I'm going to put down the 8, and I don't need to use this anymore because that was from before, and I'm going to move on now and do 10 times 10, but really I'm just going to think 1 times 1 because with the algorithm I can think of them solely as digits. And 1 times 1 is 1. Now, this makes a lot of sense to me because I just solved 18 times 10 and I got 180, which makes lots of sense. So I'm going to go back over here and fill in that 18 times 10 is 180. And now what my job is together, I'm going to add these two together and figure out what 18 times 16 is. So 8 plus 0 is 8, 0 plus 8 is 8, and 1 plus 1 is 2. And that gives me my final answer of 288. And as you can see by looking at my array, that makes a whole lot of sense because I have 180 as one part and I have 108 as the other part. And if I added those together, I would get 288. Let's try another problem, 27 times 15. So again, I'm going to start by rewriting the problem vertically, and I have 27 times 15. Now what I'm going to be doing here in this problem is solving 27 times 5 and 27 times 10. So in order to do that, it might help me if I broke apart the 15 over here in my array to show that these are the two parts that I am figuring out, 27 times 10 and 27 times 5. I'm going to start right now by solving 5 times 7 because I'm doing 27 times 5 to begin. So 5 times 7 is 35. So I'm going to put down the 5, and remember, I need to bring the tens place over above this tens place. And now I can solve 5 times 20. Because it's a 10, I know it's a 10, but I'm still going to think of it as a 2 right now. I'm not going to think of it as 20. 5 times 2 is 10, plus 3 is 13. So I'm going to put down the 3, and then I bring the 1 to the hundreds place. Now, if there was another digit here, then I would carry it over to the hundreds place, but there's not. So I have just solved 27 times 5, and I got 135. Next, I need to move on to 27 times 10. And in order to do that, I need to first put down my placeholder. This shows that I'm moving from the ones place to the tens place. So now I'm going to solve, I'm going to do 1 times 7. So I'm going to solve 1 times 7. And even though I know this is a 10, I'm just going to think of it as a 1 right now. And 1 times 7 is 7. And I don't need this. And now I'm going to do 1 times 2. And 1 times 2 is 2. Remember, I know that those are 10 and 20, but with the traditional algorithm, I can just think about them as digits. Now I'm going to add these together. Before I do that, let me go and fill in over here in my array that 27 times 10 was 270. That makes a whole lot of sense. It's important that I had this placeholder because if I got 27 here, it really wouldn't have made sense. 27 times 10 is not 27, it's 270. Now I'm ready to add. 5 plus 0 is 5. 3 plus 7 is 10. Put down the 0, bring over the 1. And 1 plus 1 is 2, plus 2 is 4. And that gives me my final answer of 405, which if I look over at my array, seems to make a lot of sense. I have 270 plus 135, and if I add those together, I get 405. One final problem, 46 times 37. So I'm going to start by writing this vertically, and I'm making sure that I'm lining up my 1s and my 10s. Now, remember that I'm going to be solving 46 times 7 and 46 times 30. Those are the two problems that I'm going to solve. So I'm going to show that right now in my array, that I'm going to be solving 46 times 30 and 46 times 7. And I'm going to start with 7 times 46, but I'm also going to break it down into different steps. So to start, I'm going to solve 7 times 6. 7 times 6 is 42. So I'm going to put down the 2, and the 4 I'm going to carry over to the tens place, okay, because I still need to multiply the 40 and 46. So now I'm going to solve 7 times 40, but I'm just going to think of this as a 4. So 7 times 4 is 28, plus 4 is 32. So I'm going to put down the 2, and there's no hundreds place over here in my problem, so I'm going to put down the 3 in the hundreds place over here in my solution. And that gives me that 46 times 7 is 322. So I can go ahead and fill that in on my array. Now, I'm moving over from the 7 to 46 times 30, and I'm going to be figuring out what goes here. Because I'm moving from the ones place to the tens place, I need to account for that by showing a placeholder. Now I'm ready to start solving. The first thing I'm going to do is multiply 3 times 6. I know this is a 30, but remember the placeholder is reminding me of that. So I can just think 3 times 6, which is 18. So I'm going to put down the 8 and carry the 1. And you might be saying, oh, but you already have the 4 there. So that might be a little bit confusing. Remember, that was from the previous multiplication. So I want to get rid of that. Now I'm ready to solve 3 times 4. And 3 times 4 is 12, plus the 1 is 13. So I'm going to put down the 3, and again, there's no hundreds place over here to carry over to, so the 1 is going to go in the thousands place over here in my answer. And what we just solved was that 46 times 30 is 1,380, which does make some sense because 46 times 3 would be 138, and 46 times 30 would be 10 times bigger than that. Now I'm ready to add these two together, and I'm going to do 2 plus 0 is 2, 2 plus 8 is 10, 1 plus 3 is 4, plus 3 is 7, and 1 is 1. And I'm getting my final answer of 1,702. And that does make a lot of sense because if you look back at my array, I would be adding these two together and I would get 1,702. Using the traditional algorithm can be confusing at first, but with more and more practice, you'll get better and better at it. Thanks so much for watching. I hope you learned a lot today.